next video, I'm going to show you similarity with volume. So in my first example, I've been given two cylinders which are similar, and I know the volume of the smaller one, but I need to work out the volume of the large one, and I've been given the heights of both. So hopefully you already know what you're doing with similarity, with lengths, and maybe you've checked out area questions as well. With volume, we're going to start exactly the same way, and we're going to write down the unknown, so V. So we need to then divide by the corresponding volume. So the volume of the smaller cylinder is 20. Now we put that equal to the sides divided in the same way. So remember, we put the larger cylinder as the numerator and the smaller cylinder as the denominator. We do the same when we're looking at the lengths. So I'm going to put 15 on top and 5 underneath. Okay, so it doesn't actually matter which way you divide these, okay? You could do it the other way around if you wanted to and you get the same answer. But it just makes your equations in general a bit easier to solve if you keep the unknown as the numerator, that's all. Okay, so I'm going to continue with this question. I know 15 divided by 5 is 3, but I'm just going to leave it like this for the moment, just so you know what to do in some of those harder questions. So the next step is to look at the units of our answer. The answer is volume, which will be in centimetres cubed, like this one. This one is already in centimetres cubed, and the lengths are in centimetres. We need to make sure that the units of all these numbers are the same as our answer, so centimetres cubed. Well, this one's all right, this one's already done, but these two are in centimetres. So we need to make sure we cube this side first so that it corresponds with our answer units over here. So the next step in solving this equation is to get rid of this divide by 20, and the opposite is to multiply. And remember, when you're solving, you need to do exactly the same thing on both sides of the equations. So on the left-hand side, that cancels, and we're left with the volume, V. And on the right-hand side, we need to calculate. So you've got that fraction from earlier, 15 over 5. And we have to cube that one, remember, to turn those centimetres into centimetres cubed. And then you will multiply that answer by 20. So you can just pop that in the calculator. I'm going to have a go at doing this in my head because I don't think it's a too tricky one here. So I've got 15 divided by 5, which is 3. Don't forget we've got to cube that number, and then I have to multiply by 20. Well, 3 cubed is 3 times 3 times 3, which is 27. Then I need to multiply by 20, which gives me 540, not forgetting the units, it's centimetres cubed. So I've worked out the volume of the larger cylinder. Okay, on to example number 2. Okay, so here's another volume question, except this time I know both the volumes, but I need to work out one of the lengths, this one here, x. So we're going to start exactly the same way, and I'm going to write down the unknown. So I'm going to write down x, and I need to divide that by the length in the smaller cuboid. So I'm going to do the large length here divided by the small one. Remember, you then need to divide the volumes in the same way. So remember, we've got the large cuboid as the numerator and the small one underneath. So I've got the large volume on top and the smaller volume underneath. So just like before, we need to look at the units of our answer. And our answer is going to be in meters. Well, this length is already in meters, but these ones are volumes and they're in meters cubed. We need to make sure all the units are like the units in our answer, so in meters, before we can solve the equation. So we need to get rid of these cubes over here on the meters cubed. So the opposite of cubing is cube rooting. So to get rid of these cubes, you need to cube root the right-hand side. Okay, because then that will cancel the cubes and you'll be left with meters. Then everything will be in meters and you can solve the equation. So I could simplify here 24 over 3, but I'm just going to leave it like this, just so you know what to do when the questions get a bit harder. So what we need to do next is get rid of the denominator. So the opposite of dividing by 2 is to multiply by 2. So I'm going to times by 2 on both sides of the equation. on the left hand side that just cancels and I'm left with the length x. And on the right hand side, I need to cube root this answer, remember, so that big fraction. Make sure you cube root all of it and not just the numerator when you put it in your calculator, and then not forgetting you times all of that answer by 2. So you could just put that all in the calculator and that will work out the value of x. I'm going to have a go at doing this in my head because I think it's quite an easy one. So 24 divided by 3 is actually 8. So I'm going to change that fraction to the number 8 and I need to cube root that number before I times by 2. The cube root of 8 is 2 because 2 cubed is 8. 2 times 2 times 2 is 8. So I've actually got 2 times 2, which is 4. So the length of that larger cuboid here is 4 meters, sorry. Okay, so there are 2 examples on similarity and volume. Soon I'll have some videos where I'll have a go at some exam questions with some challenging questions on similarity, and it might be a combination of area and volume in the question. You might need to cube root, then square, to make sure, just like in this example, that all the units are consistent before you calculate the unknown. So I hope you understood that video, and that's bye-bye from me.